In this video, I'm going to do a little bit of review from Algebra 2 Trig or Precalculus on vectors in a plane, just some basic reviews, and then we will move on to some vector calculus in my next video. Okay, so just as a reminder of vectors. Vectors an ordered pair of real numbers denoted in component form as AB, where A is typically the x direction, B is the y direction. So this is our A, and that's our B. The magnitude or length of the vector is the square root of A squared plus B squared from the Pythagorean theorem. And the direction, so this theta, which comes from the positive x-axis rotating up counterclockwise, is going to be tangent of theta, we know, is b over a, so we have to do the inverse tangent of b over a equaling r theta. Okay, given that vector, sketch the vector, find its magnitude, and find the direction. So I go -2 up to root 3. I'm going to approximate that. I don't even know what 2 root 3 is. I'm not going to pull up my calculator. Our vector looks something like that. Its magnitude is the square root of -2 squared plus 2 root 3 squared, which simplifies to be 4. Now the direction that I need to find is that theta. Okay? What I'm going to do is I'm going to use the idea of reference angles. So I'm going to find this angle alpha here. And what I'm going to do is I'm going to do the inverse tangent of 2 over 2 root 3. Just simplifying that. We have that. Now, what angle is my tangent? Essentially root 3 over 3. Well, that's going to be 60 degrees. So that's what my alpha is. And I chose to use the absolute value of -2 just because I was just looking at this right triangle. If I use the negative version, remember your answer, even if you're using your calculator, would have been down here in quadrant 4. So that's why I use the absolute value. Now what am I really looking for? I'm really looking for theta. So I'm going to do 180 minus 60 is going to equal my theta. So that's how I get 120. Find the component form of a vector whose magnitude with a magnitude of 4 and a direction of 55. So looking at it like this. Magnitude is 4. My direction here, theta, is 55. I need to find the A component. I need to find the B component. Well, what do we know about A? A is equal to, actually no, I don't like A is equal to. I'm looking at 55 and I'm saying that 55 and A, well that's going to be the cosine, I can't spell the day, it is the morning. Cosine of 55 is equal to A over 4, so A is equal to 4 cosine of 55, and finding that in my calculator I get 2.294. For B, the sine of 55 is equal to B over 4. So B is equal to 4 sine of 55, which equals 3.277. So my component form is 2.294, and 3.277. The shortcut way to find your components, the A component is the magnitude times the cosine of the angle we were given. And then the y component, or the b component, is the magnitude times the sine of theta. How I personally remember that is on our unit circle, the x's, or the a component, was cosine, the y were the b components. Okay, vector operations. This hopefully seems intuitive or easy. When you're adding two vectors, you add the like components. A scalar is when you're multiplying a vector times a value, and then an opposite vector, you're going in an opposite direction. So how I look at it is, if vector v is going that way, same magnitude, complete opposite direction is negative v. A visual representation of adding vectors. This is the one I'm going to use. This is the one that Mr. Jeans and Mr. Kelly both use, our physics teachers here. So if I start here at A, my initial point, go through vector A, you end at the tail of A, and then, or I'm sorry, the tip of A, and then the tail of B starts, and you draw B, your resultant vector is from the initial point to my terminal point, A plus B. You could also use the parallelogram method. Some teachers use that. We have chosen at De La Salle not to use that, so that's why I do the tip to tail method. Okay, now some properties of vectors. I just personally I just consider these some basic algebraic properties. So if I'm doing 2u plus 5v, 2u is 10, 8. 5v is negative 10, 30. I add those. To get that. So 9v minus 3u, I'm going to do my work above just because I don't have a lot of room below. 9v is equal to negative 1854. 3u is equal to 15 and 12. Now I subtract those. To get negative 33 and 42. Okay, this application. The airplane problems, I don't know why I love these airplane problems. I think that they're just such fun applications of vectors, because I personally think of a vector as an airplane. So a plane flies due east at 500 miles per hour. So here's my airplane. I'm going to call it A for airplane, and it is going at 500 miles per hour. Just so you know, that's the magnitude. And there is a 70 mile per hour tailwind acting in the degree of 60 degrees north of east. So looking at that just in terms of north, south, west, east, 60 degrees north of east would look something like that with a 60-degree angle there. I now need to find the new ground speed of the airplane. So what that means is really where at the tail, or I'm sorry, at the tip of our first vector, we're going to have the wind acting on it. at a 70 mile per hour clip, where this angle here is 60. That's really small because I don't want to be able to see it. I don't want you guys to get confused with that 70. Let's call this vector W. So let's write A in its component form. A in its component form is going straight in the x direction. W in its component form is the magnitude, which is 70. The x component is cosine 60 plus, I'm sorry, not a plus. The y component, or b, is 70 sine 60. Now what I would do is I'm trying to find a plus w. So I'm going to type 500 plus that in my calculator, and I'm going to get 535. I'm going to type this in my calculator, and I get 60.621. Now I'm looking for the speed. So the speed is the magnitude of this vector. So square root of 535 squared plus 60.621 squared. Speed is magnitude. So I find the speed and I get 538.424. To get the direction, I do inverse tangent of my components. And I get the angle of 6.465. Now let's look at why that makes sense. Because my wind, if you look at the wind, it's pushing my airplane that way. So my resultant vector of a plus w is that. That makes sense that that's a really small angle. Okay, so that is it for our introduction to vectors. Hopefully that was a review of things you have seen before.